What is the information from the laser transmitted 16 million kilometers from Earth that NASA has captured? It is the first occasion on which the United States Space Agency has managed to send and receive communications from such a considerable distance, using the Psyche probe, which is en route to an asteroid for study purposes. From a telescope on Earth, a laser beam is sent to a probe located 16 million kilometers away, according to NASA. The U.S. Space Agency is exploring innovative methods of space exploration, including the study of alternative fuels and the improvement of communications with its spacecraft traveling through the solar system. For this reason, an experiment is underway that could change the way spacecraft communicate with Earth. Specifically, NASA received a laser message transmitted 16 million kilometers from Earth through the Psyche probe, which is heading towards an asteroid of the same name in the coming years. To grasp the distance between the sender and the receiver, it's worth noting that the Moon is only 384,400 kilometers away. It is an experimental essay on laser communications associated with the Psyche mission, which has transmitted its initial data, thus demonstrating the use of laser communications in deep space exploration missions. The experiment, known as Deep Space Optical Communications (DSOC), is integrated into the Psyche spacecraft, which is en route to an asteroid in the main belt between Mars and Jupiter, following its launch last month. The device emitted an infrared-encoded laser containing precise details about the location of the Psyche probe. Its destination was a reference point located at the Hale Telescope, situated at the Palomar Observatory of Caltech in California, United States. Never before had precise laser communication been achieved beyond Earth's orbit. The management of communications for NASA's deep space missions falls under the Deep Space Network, a network of antennas located in 3 places around the world that primarily relies on radio frequencies. However, laser communications could provide 10 to 100 times more bandwidth capacity, so NASA is seeking to conduct experiments with this technology, especially in contexts such as the transfer of scientific data. The DSOC transmitted test data from a distance of nearly 10 million miles on November 14, beaming them via laser to the Palomar Observatory at the California Institute of Technology in San Diego County, California. This event is referred to as the mission's first light. According to Trudy Cortez, who serves as the Director of Technology Demonstrations at NASA, this achievement is extraordinary. Reaching first light is one of the numerous crucial milestones for DSOC in the coming months, paving the way for higher-speed data communications that will enable sending scientific information, high-definition images, and video transmissions in support of the next major human breakthrough, sending people to Mars, stated Cortez in a release. The test is more challenging compared to using radio waves for communication, as radio waves disperse over a wider area during their journey, making reception easier. In the case of laser communications, a narrow beam is used, requiring careful alignment between the spacecraft and ground facilities. This test marked the first instance in which ground resources and the flight transceiver were fully integrated, requiring close collaboration between the operational teams of DSOC and Psyche, mentioned Meera Srinivasan, who leads DSOC operations at NASA's Jet Propulsion Laboratory. It was a significant challenge, and there is still much work to be done, but for a brief period, we successfully transmitted, received, and decoded some data, she added. The DSOC experiment will extend for an additional 2 years, primarily focusing on the use of test data, although there is the possibility of transmitting data from the Psyche spacecraft. Since the spacecraft also has conventional radio communications, this would be considered simply as an evaluation of functionality. Should the system prove reliable, laser communications could play a key role in enabling missions to send large volumes of scientific data to Earth in the future. Optical communication represents an advantage for scientists and researchers looking to get more out of their space missions, facilitating human exploration of deep space. A higher volume of data translates to more discoveries, stated Jason Mitchell, who leads the Advanced Communications and Navigation Technologies Division in NASA's Space Communications and Navigation (SCAN) program. It is worth noting that NASA's Psyche probe gained notoriety as it heads to explore an asteroid sharing its name, estimated to contain minerals valued at $10 trillion, though the exact figure is uncertain. It's not surprising that it is popularly referred to as the Golden Asteroid. What is the information from the laser transmitted 16 million kilometers from Earth that NASA has captured? It is the first occasion on which the United States Space Agency has managed to send and receive communications from such a